So, if you guys are brand new to this channel, lately I've been making videos about Mars because we've seen there's a lot of new discoveries, not just on the atmosphere, but also down on the Martian surface, where we discovered, minerals and rock types, and showing the actual true colors of Mars by showing like how chemical reactions play a role into shaping the Martian surface by seeing like acids and sulfurs and other things that are giving Mars a different look and how we interpret interpret what Mars's surface color looks like. And also we want to see the dynamics of how does the thin atmosphere play a role in shaping the surface of Mars. Uh, if I've been following since November, the ESCAPADE mission. These are the twin orbital spacecrafts that's currently 550,000 miles away from the Earth's surface. And right now they're doing an L2 orbital Lagrange point that's heading straight to Mars. And if you guys don't know about that, because this is a newer, quickest, fuel efficient way to get to another planet without just straying along and finding where Mars is in its orbit. And the reason why it takes so long to do this mission by doing an L2 because you have to constantly orbit around the Earth, you have to pick up enough speed, and then you have to leave Earth's orbit once you have enough speed, and eventually it will embark on 9 months to get to Mars. So the total is 22 months, but that is actually fuel efficient and also a very efficient travel way when you go to an interplanetary mission. So basically, the twin escapade mission are doing a remote sensing, understanding the dynamics between the sun and the Martian atmosphere. And this is a video by NASA Goodard that's going to be animating, what's going to play on with, the twin spacecraft that's once they get to Mars. And once they get to Mars, which is going to be late 2027 into 2028. So expect new samples and missions once we get the twin spacecraft straight to Mars. Because right now they're still around low Earth orbit, and they're like I said, they're building up speed, but it's gonna be a long time once they start heading to Mars.
Mars, once a warm, watery world with a thick atmosphere.
Yep.
Now, a cold, arid landscape with its atmosphere thinned out. What caused this transformation? Over billions of years, a relentless flow of particles from the sun, the solar wind, has slowly stripped away the Martian atmosphere, causing surface water to evaporate. But how exactly did this happen?
So pretty much when Mars, actually, let's kind of go back a little bit, and I've done a couple of videos talking about the history of Mars. So we can play along with 2.5 billion years ago. There was an extreme glaciation due to the abundance of when Mars first had life forms, like first proto life, stromatolites that were taking a lot of that CO2 and then just releasing abundant amounts of oxygen. And when you have the extreme abundance of oxygen that's all the way left and there's not enough carbon dioxide, temperatures can plummet so far down, creating what we call a snowball Mars. Because Earth and Mars did have a snowball period because of that increasing of oxygen. But there's something that played a role in shaping what Mars is, because Mars went through multiple glaciations that really ruined Mars, ruined Mars so much that you know not just the surface took effect and changed because leftover bits of water that was exposed to the oxygen and all the sun rays caused it to rust, but also it changed the interior of Mars, where all that ice seeped in and then the core stopped and it froze over and pretty much weakened the magnetosphere so much where it was so vulnerable by the solar flares and the solar particles that were penetrating Mars, blasting Mars with constant solar radiation, we're left behind just a CO2 thin atmosphere. And here's the thing with CO2. CO2 is a very heavy element, like a very heavy gas. So that's pretty much what happened to Mars around a billion years ago.
Happen, and how could it affect future Mars explorers? NASA's new ESCAPADE mission aims to find out. The Escape and Plasma Acceleration and Dynamics Explorers mission is studying the planet's real-time response to the solar wind, helping us understand Mars's climate history using two spacecraft in orbit for the first time.
Past missions that we've sent to Mars to understand the interaction of the solar wind with the planet have only been single spacecraft missions.
Okay.
So ESCAPADE gives us what you might call a stereo perspective, two different
Wow.
vantage.
So this is really good. Yeah, giving you a kind of a double remote sensing, where if you see in this, sorry, I'm gonna change. I'm gonna turn off these captions real quick so we can actually understand some of this. So let's turn this off real quick.
Points simultaneously. This will allow us to really make
Okay,
measurements.
so understanding the graphics up here. So the twin spacecraft are called Blue and Gold, and what they're up to is once they get to Mars, they're going to be aligning themselves as they're going to chase each other around Mars, and then they're going to kind of reshape, their orbits between a high and low orbit. So I'm guessing that the Gold craft is going to be in a low orbit. I'm guessing that the blue one is going to do the exact opposite. We're going to be in higher, more elliptical orbit, where they're going to just be in sync gravitationally against Mars.
Allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it.
And what's so good about this high and low trajectory, because you have two fields of views. Basically, one. So I think if blue is right here and it's sinking other parts of the Martian atmosphere in different halves of Mars, and then eventually you have the low orbit around Mars being the gold, where it shows another field of view on a different hemisphere of the Martian atmosphere as well. So you're giving a double field of view in between multiple different hemispheres
simultaneously. This will allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it before.
ESCAPADE's twin spacecraft fly in two different formations to see how Mars responds to the solar wind in both time and space.
This is the first time that two or more spacecraft have worked out a formation in orbit about another planet, in this case Mars.
In the first formation, nicknamed the String of Pearls, the two spacecraft chase each other.
Yeah, so they're going to chase each other, like I just said. Like I said, one will carry out a different hemisphere where they're analyzing this, and then there's another field of view where between the gold, we'll have another field of view of a different hemisphere of Mars, where you're saying like so there's different samples that they're collecting on different parts of. Like I said, if you have something towards the North Pole, let's see how the atmosphere plays out on the North Pole versus also on the South Pole, or on the Eastern Hemisphere or the Western Hemisphere, whatever. Like I say, it just determines on where they are in their orbits, basically, as they kind of rearrange themselves.
In nearly identical, highly elongated orbits. This allows ESCAPADE to observe rapid changes in the Martian atmosphere caused by sudden variations in the solar wind.
When we have two spacecraft crossing those regions in quick succession, we can monitor how those regions.
So yeah, you want to see different hemispheres of just how you're going to fit, phase between Mars and the sun, so you can get a better contrast of incoming solar radiation, because you want to see it in more of an increased solar radiation in a different part of the hemisphere, and you want to see another backside where how the magnetosphere also interacts with the sun on a different side of view.
Vary on timescales as short as 2 minutes up to 30 minutes. Before we had to wait for 4, 5, 6, 7, 8 hours.
In the second formation, the spacecraft have different orbits that are more separated from each other,
Okay.
allowing ESCAPADE to study both the solar wind
Yep, so you have a two different field of view.
and the upper atmosphere of Mars simultaneously for the very first time.
We'll have one spacecraft in the solar wind so we can measure what's coming in, and then one space.
So I think gold is actually going to be covering the inner part where we can actually be in the leftover bits of the magnetosphere, how we see the interaction of the sun.
Craft closer to Mars. This will help us understand the cause and effect of what's happening when space weather comes to Mars.
ESCAPADE will not only fill gaps in the story of how Mars's atmosphere changed, it will also help us prepare to send human explorers to the Red Planet. For example, ESCAPADE will give scientists more details about Mars's ionosphere, a part of the upper atmosphere that future astronauts will rely on to send radio and navigation signals around the planet.
Understanding how that ionosphere varies will be a really important part of understanding how to correct the distortions in those radio signals that we will need to communicate with each other and to navigate on Mars.
ESCAPADE's work could also help keep future Mars explorers safe.
Atmospheres can provide a shield that protect humans and other assets on the surface from things like solar radiation or intergalactic radiation. So it's important for us to understand how the atmosphere is changing in order for us to know what we have to do to protect humans and other assets we might put on the surface.
In addition to new science, ESCAPADE is pioneering a new way to reach Mars. Previously, spacecraft
this is what I mean. So instead of doing that, that direct, interplanetary, transfer,
launching to the Red Planet had to wait.
Because here's the thing, Mars and Earth are in a completely far different orbit and different sides of the sun, where for a rare
years for Earth and Mars to line up.
For a rare occurrence for the Earth and Mars to align varies around 26 months. So every 26 months is when we have both planets to align. But that's a very rare occurrence that happens frequently. But like I said, it's every 26 months. So planning missions to go to Mars, like I said, and also going back, you still have to wait for that configuration to line up. Which, like I said, 26 months. That's 2.5 years.
However, ESCAPADE is launching into a unique orbit that loops around a region in space known as L2.
So this is a kidney bean shape. L2. Yep. So L2, this kidney bean shape, following around Earth's trajectory until they pick up enough speed, and then, eject themselves out of Earth's orbit into trajectory of Mars.
Roughly 1 million miles away. Then, it'll return and use Earth's gravity to slingshot itself to Mars.
Boom.
This allows ESCAPADE to launch.
Okay. So yeah, I think I did a whiteboard analysis showing that trajectory. So a kidney bean shape returns back to Earth, and then once it picks enough speed, bam, it's always slingshotted into a new 9-month journey to Mars.
Early and wait in space until the two planets are in the right positions. This first of its kind orbit will also make ESCAPADE the only spacecraft to ever pass through a distant part of Earth's magnetotail, before beginning its 10-month cruise to Mars and starting its cutting-edge work there.
NASA's heliophysics fleet is looking at the sun's influence, and with ESCAPADE, we'll now have multi-point measurements at Mars, which will help us have a more comprehensive picture of what's happening throughout the solar system. We need a solar system-wide understanding of space weather in order to protect our technology and our astronauts wherever they go.
Yeah, that's actually very well put together, and a lot of data sources from scientists understanding, just the trajectory, space weather. It all comes down to just what the sun is doing, because we've seen so much solar activity right now where we see rare occurrences where solar, these auroras have been as far south as Florida. It's spectacular to see auroras that far south, because usually we see them up in Canada, for example, or we see places like the Great Lakes regions or the northern part of the United States. But where it dips down so far deep into the south, where that's a very rare occurrence, because like I said, it's this increasing solar activity that occurs every once 11 years. So during that 11-year cycle is pretty much where the sun throws its biggest tantrum, where it ejects so much of these solar flares and these solar winds that become so active, where it interacts with the Earth's magnetosphere. But we also see that with Mars as well. We want to understand that grace period of how the sun's activity works during a grace period versus how the sun looks during its temper tantrums on Mars as well, to study the dynamic changes between when the sun throws its temper tantrum and how Mars intersects these temper tantrums. So that's pretty much what we wanted to understand about the ESCAPADE mission and understanding future Mars explorations by studying the surface and also studying the atmospheric weather, the atmospheric thermodynamics, and the dynamics of Mars. So I'm going to leave you off this video. Thank you guys so much for watching. I'll see you guys in the next video. Bye.